Assalamualaikum and greetings. I wish to panels and viewers. My name is Muhammad Akmal Arman bin Saiful Madzi and my metric number is 194350. As part of the program, I'll be presenting about my findings of my bachelor project entitled Phytoremediation Method in Treating Contaminated Soil. These are the contents of my presentation. For today, though, the focus will be given on the results. For a brief introduction, phytoremediation is a plant-based process of removing pollutants from the environment or to reduce its harmful effect. It has various sub-processes, namely phytoextraction, rhizofiltration, phytodegradation, phytovolatilization, and phytostabilization, as illustrated on the diagram at the right. There are numerous plants that are capable of performing phytoremediation like Indian mustard, sunflower, rice, and tomato. Undoubtedly, mining activity is causing heavy metal contamination into the groundwater and water bodies, which can be dangerous if ingested. While numerous studies have established that plants like sunflower and Indian mustard are capable of performing phytoremediation, albeit with varying effectiveness, its condition or even its health throughout the process is uncertain. Thus, that is what the study will address. The aim of the study is to evaluate the contaminants tolerance by selected plants while still performing phytoremediation, in this case phytoextraction, as well as investigating the influence of contaminants on the soil. The objectives of the study are as shown above. In short, the scope of study is using Indian mustard and sunflower. The soil is laced with lead nitrate to replicate pollution. Only particle size distribution of the soil is studied. Daily measurements of soil pH, moisture content, and number of leaves, as well as measurement of stem height and root length. While there are numerous articles from which this project is researched, two studies really laid out the foundation, namely the study by Rewards and others in 1998, in which he suggested that all lead ions would be removed from the soil rising beyond pH 6. Turan and Estringo, on the other hand, suggested that the phytoremediation process can be facilitated by the use of chelators like EDTA. The execution of the project can be summarily described as a 28-day-long observation of sunflower and Indian mustard samples. In line with the first objective, a sieve analysis is conducted on both natural and contaminated samples. Chemical testing only consists of measuring of soil pH of each samples every day for 28 days to determine any trend line. Naturally, all the samples will require care and monitoring like any other plants would. Throughout the monitoring, number of leaves and physical changes are noted to determine its health. As we proceed with the results, here is a table listing the descriptions, the amount of contaminant, and its subsequent annotation. This table should prove useful to refer back as we look at the graphs. By performing a sieve analysis, I have determined that both soil samples, natural and contaminated, to be of clay sand. However, the lead-contaminated soil seemed to be finer than the natural soil, which actually contradicted an earlier study. This discrepancy could be attributed to the use of soil grinder to break apart the contaminated soil since it hardened into very large clumps as it dried. Based on numerous studies, we can project other soil properties based on the particle size distribution. A reasonable conjecture would suggest that the finer contaminated soil would have lower shear strength and lower permeability than that of natural soil. As stated in the literature, we would like to observe the trend line of the pH of the soil. In this instance, the sunflower and Indian mustard are tested in three varying concentrations of contaminant. By referring the three graphs, it seems in all contaminant variable, Indian mustard specimen always rose above pH 6. On the contrary, all sunflower specimens had dipped down, becoming more acidic. Thus, it could be claimed that Indian mustard is better at phytoextraction than sunflower. However, the regression value of sunflower's data were alarmingly low, thereby the result could be disputable. Onwards to plant growth observation. As we know, plants synthesize their food by the process of photosynthesis by deriving from energy of the sun, and this process only occurs in leaves. Therefore, a healthy growth leaves are needed to sustain their development. To make the three graph comprehensible, a linear trend was drawn to evaluate its significance. If you redirect your attention to the linear equation on all figures, the Indian mustard samples always have the larger negative gradient than sunflower. The regression value in all equations is quite decent, thus the data is acceptable. With that being said, sunflower had higher tolerance than Indian mustard. Unfortunately, the data of stem height and root length are only available for sunflower, thus no comparison can be made between the two species. However, literature review reveals that root length will determine how well plant would fare in reaching deep into the ground for water and contaminants, as well as stabilizing the soil. In short, longer roots mean greater soil shear strength. With that being said, the higher the amount of contaminant, the more the plant loses out on the ability of stabilizing the soil and removing the contaminant. Generally, wilting is a direct cause of depleting rate of transpiration or lack thereof, as depleting chlorophyll is for chlorosis. Undoubtedly, the reduction of chlorophyll concentration due to lead contamination directly resulted in yellowing of leaves. Also, the decreasing root length may also correspond with the decreasing rate of transpiration, which in turn lead to wilting. Regardless of the amount of contaminants, both species' condition deteriorate significantly. In conclusion, all three objectives are met. A comparison between natural and contaminated soil was conducted and it was found that the latter is finer. Based on the pH trend line, Indian master samples managed to complete their phytoremediation process compared to sunflower samples. The act of increasing the pH to neutral itself is an upside, less chance of corroding the substructure or disrupting the groundwater pH. Observation of the appearance showed that both species suffered from discoloration and wilting throughout the study due to decreased rate of transpiration and chlorophyll concentration. Although Indian mustard samples had the worst leaf loss compared to sunflower, Indian mustard still proved to be better option at phytoremediation. As for future recommendation, it would be wise to investigate other soil chemical properties that could prove useful in an environmental impact assessment report. Perhaps conduct an atomic absorption spectroscopy as well to validate the presence of contaminant inside the specimen. For maximum control environment, a greenhouse should be considered. Lastly, it will be interesting to perform a biomass energy study to determine the heating value of the contaminated plants as part of the green energy sustainable effort. And that concludes my presentation. Thank you.